Industrial control systems, or SCADA systems, are an integral part of all of the critical national infrastructure and really an integral part of everybody's lives. There's been a great deal of talk about the risks associated with industrial control systems and whether or not they're open to attack, whether or not people would actually attack them or not. And what we felt within CREST was that it was necessary to go away and actually do some really proper research to establish, first of all, are there real threats out there? Secondly, who are the threat agents who are likely to attack it? And then thirdly, what we should do as an industry to actually help move forward the concept of much greater levels of assurance in terms of industrial control systems. It's part of our knowledge sharing and it's part of our research. And again, all of the research that came out of this particular activity is both IPR and IPR free. And really what we did was we produced a particular guide in this particular area, describing the workshops that we ran, describing the collaboration we've had with industry, both in terms of those people that are doing penetration testing, as well as those who are developing SCADA systems, but also with the buying community from those areas to make sure that whatever it is we define in terms of technical assurance would be fit for purpose. The background to the project itself is a review of some of the existing standards and some of the existing work that was done in this area. In the UK, particularly some of the work from CPNI, and in the US, some of the work that was done by NIST. So we pulled together that background research to understand what standards are available and what type of things those standards are looking for. But in addition to that, to look at some of the threat scenarios, some of the real things that are happening, to establish whether or not the level of assurance that was going to be provided was appropriate, fit for purpose, and was actually protecting those systems that are important to our critical national infrastructure, the provision of power, light, water, all of those other aspects that have a control systems associated with it. And we believe it's a really important project, and what we're trying to do here is to establish a way forward for the community. We broke down the results of this in terms of 4 basic areas. The first one is business assurance. So in other words, looking at the assurance method, looking at the management processes, and making sure we understand what elements are actually critical. When we talk about industrial control systems, it's obviously very easy for us to identify a switch that turns something on or off, but the management control systems that have to enact to allow that switch to take place, it is a very important concept. And in addition, if you wanted to attack some of these systems, you might not actually attack the switch. What you might be doing is attacking the management system behind it. So that business process is very important. The ability to provide education and training in this area is also very important. There is a real lack of any proper training in this area in terms of security of industrial control systems. What we've also done in terms of our engineering practices to pull these things together is to pull them together in terms of a resilience perspective. So in other words, to make them fault tolerant and less likely to fail. The difference here is we're actually looking at people that are attacking them. So in other words, a weakness that we can actually provide some level of continuity or contingency is not necessarily appropriate in terms of looking at it from an attack perspective. If I was an attacker, I would attack the back office systems first or the backup before I attack the primary, because then you're actually destroying the whole process and you're putting the whole thing at ransom. From our perspective, the technical capability and understanding the technologies and actually looking at those technical vulnerabilities is an important part, and really I believe some of the most critical parts. It's very easy for us to say what we need is the management processes in place, and really the individuals and people are the weakest point, but if we haven't got proper controls from our security perspective, from a technology, then really I think we're in an extremely poor position, and it doesn't matter what controls you put over the individual or what management processes you put in place, you're still vulnerable. And finally, the infrastructural environment. So in other words, how it fits into an overall architecture or infrastructure. Again, if I was looking to attack these types of systems, I may well attack the periphery first before I go into the primary. So what we're trying to do here is to understand the infrastructure, understand the component parts and the criticality, and really the critical elements associated with the different functions to make sure all of those are fit for purpose and we have a level of assurance that provides support across the whole piece. In terms of looking at this, we initially did research work, interviewing people in the supply industry, in other words, those who build industrial control systems, those who are responsible for implementing them and managing them, as well as those that have actually conducted technical tests, and some people that have been involved in some incident response. Some of the difficulties they described was initially the rapid change. There's a significant change in terms of how industrial control systems are controlled and whether or not they are linked onto the internet in some form or another. All the time they were isolated systems, they were less vulnerable because you actually had to get into the physical environment or at least into the technology environment to facilitate some form of attack. As soon as we open up those systems onto the internet, then we're in much greater vulnerabilities because a lot more people have potentially got that ability to mount an attack against it. It's also very technically demanding. So in other words, from two perspectives. The one is in existing industrial control systems, there's a lot of old technology that's out of maintenance, out of control, can't patch anymore. And also we're very concerned about how we patch it because we can't take it down. But in addition to that, that technical demands is fully understanding both the attack vectors, how these things would operate, but also the deep dive technical environment in which they're operating. So to do this properly, we have to have, I believe, a multidisciplined team. You have to have people that understand the threat, you have to have people that understand the type of attacks that might be mounted, and as well as understanding the detailed technologies in terms of how it's been built, how it's operated, and how it's controlled. That's combined with an interesting lack of management support was the feedback we've got. Whilst there's an awful lot of talk about making sure these systems are resilient to attack against a state-sponsored attack or resilient to attack against a ransomware type activity, in actual fact management don't know how to provide direct support. They can put money, they can put resource in there, but really what they need to do is to focus that in a way that actually makes a difference. So that concept of how can management most effectively spend their money is really important. And the lack of standards in this area then causes that a difficulty. It's very easy for a management team to say, we want to move towards an ISO 27001 certification, or we want to meet a particular standard. Where those standards don't exist, it's very hard for them to specify and actually move forward in terms of understanding what good looks like, both in terms of their peer groups and in terms of the wider community. In addition to that, I believe that any of this stuff should be properly threat-based. So in other words, we could come out with a whole pile of different threat scenarios, we can come out with a whole pile of different ways we could potentially attack the systems, but what we need to do is to make sure that the ones we're actually specifying, the ones we're testing against, are the real life things that we're actually doing, or the real life things we're seeing within the environment. And that means we need to tie in the threat intelligence providers to really understand what's happening on our systems and networks, to identify who's likely to attack us and what types of tools and techniques there are. I think, again, that would really help in terms of management's understanding, because you're then not saying what we need to do is to improve security because of some esoteric attack. What we're actually saying is we need to improve security because there's evidence that these particular threat agents are operating within the areas, and these are the particular attack vectors or attack techniques they're using in these types of environments. So in other words, we can be much more specific and I believe much more persuasive in terms of how we move forward. We had some really interesting comments back from the industrial control systems community and the industry itself. One of the most interesting ones from my perspective was, why would we be a target? Why would somebody attack an industrial control system? Well, if you look at it from a state-sponsored attack perspective, absolutely. The likelihood of a state-sponsored attack, I believe, is quite low, but we need to guard against it. We need to make sure that controls are in place that would protect our systems against this form of attack. But if you look at ransomware, if you look at the ability to disrupt, if you look at the ability to gain headlines in terms of bringing things down and overall confidence in terms of the ability for us to protect these types of systems, I also believe it is a really important concept that we need to consider. So in other words, whilst we might not believe we're a target because anybody's going to make any money at it, in actual fact we can be a target because of the inference it provides in terms of our ability to have good governance and good confidence in terms of the systems that we provide. The other part is, why would somebody attack an industrial control system? Again, state-sponsored is a very obvious and most widely stated, but again, ransomware, the ability to disrupt a marketplace, the ability to move a marketplace in particular directions are also things that I think we need to consider. Our systems are not connected was one of the other statements that were made. And I think that's a fairly naive position because we are seeing a lot more connections into IP address ranges. We are trying to do remote management of these systems because it's the most effective way and the cheapest way of doing it. So whilst historically we've had this isolation view where we've got the system working all on its own with no outside connections, if that hasn't changed now, I believe it will change in the future. And what we need to do is to make sure we're protecting the periphery, to make sure we're protecting the heart. In other words, controlling the access and entry points to make sure we're not vulnerable to attack from external sources. Our technology is not a target. Again, that's a reasonable statement to make. A lot of the specifically generated systems are not generally what you see in terms of general threat intelligence or what we're seeing in terms of some of our incident responses. It's not the normal things that you would attack in terms of Microsoft or some of the other platforms. But given the level of impact, what we have to consider is that it could be. And in addition to that, because a lot of it is based on old technology, it's likely to be vulnerable. So therefore, this concept of our technology not being a direct target, again, we can attack the periphery, or I believe if we're actually having a considered and concerted attack, then they will actually attack the infrastructure itself. We are secure, but we're not secure about our supply chain. I can't understand how you can actually say that you are secure if you've got no confidence in your supply chain in the first place. So therefore, we need to put standards controls into our supply chain to make sure that those supporting environments are actually supporting the organisation and the critical national infrastructure or industrial control system we're speaking about. But in addition to that, I also believe that what we need to do is to look at it from a technical assurance perspective. I think there's been excellent work to make sure they're resilient, make sure they're self-recovery, self-repairing, but I think it's very different if we move from that sort of accident into an attack, because I think the overall approach to looking at how you attack a system is very different from how you recover from a fault. We have plans in place to deal with incidents, and that's absolutely true. So in other words, what we do is we close things down. If it's an air traffic control system, if we haven't got any trust, we ground the aircraft. If we're really worried about a power distribution or a water plant, then what we do is we close it down. That has the impact that the attacker may well want. So in other words, whilst you have got plans in place to deal with traditional incidents, a cyber threat is quite a difficult thing to manage because you don't know when it's clean. So in other words, just to mount or potentially mount a cyber attack in this area would mean you'd have to close the systems down. And then you've got to go through a whole process of making sure it's clean, which is a very different technique and a different process than we have available to us in terms of the types of incidents we normally deal with on failure. What are we trying to do as an industry? What we're not necessarily trying to do is look at the traditional information threats. I believe these systems should meet minimum standards, and they should be looking at good techniques in terms of normal management of cybersecurity related activities. But what we should be doing within the industrial control system space is looking at those cyber attacks that are coming from serious organised crime, those that are coming from state-sponsored attack, or those that are coming from extremist groups. Those organisations or those types of organisations have got a great deal of resource available to them, and really they can amount quite structured and quite consistent and long-term attacks on these types of environments. It could be the case that some of those already exist and they're waiting to be enacted and they're already available on our system. But really what we're trying to do in this area is to make sure that we have things in place to protect us against the more serious and more professional type attack areas. In terms of trying to roll this out, then what we're looking at doing is looking at the different areas where industrial control systems apply, and we're trying to develop schemes that help provide a consistent level of technical assurance. A scheme is a combination of assurance in terms of the company itself that's providing services, so to understand they're fit for purpose and they're meeting minimum standards, but also the qualifications of the individuals working within those areas. The concept of trying to do this in a consistent way across the whole of the critical national infrastructure will not only improve security, but it also improve in terms of reduction of costs, because we're not reinventing the wheel for every type of industry that we have in place. This is a really important thing. There's a great deal of talk about attacks on government systems and industrial control systems, and I think it's incumbent on us as an industry to actually have an answer to both ministers, governments and others that are asking questions about how secure and what level of assurance we've got in those important industrial control systems. There's been a great deal of talk about how we control and how we provide assurance in terms of industrial control systems. And as an industry, what we've tried to do is to come together in collaboration to understand what we need to do that's in addition to normal technical assurance activities, such as validation of standards, such as validation of policies and processes, and validation through penetration testing of the technical architecture. In terms of traditional penetration testing, then I believe it's fit for purpose for the vast majority of the attack scenarios that we're looking at. What we're doing there is we're drawing the expertise in from the individual, we're validating that individual's expertise, we're using standards and we're using forums and we're using background information to understand what the threats look like. We're also using advanced tools, and we're also using the expertise of the individual to look at that attack environment or the target environment to make sure our penetration tests are appropriate. So what's different in terms of critical national infrastructure and industrial control systems? I think, as I've said, the existing standards are more than fit for purpose for the vast majority of their targets. So again, that validity in terms of the level of criticality is the starting point. We don't want to spend a significant amount of money on a system that is either unlikely to be attacked or in actual fact doesn't demand the same level of control. But for the high criticality ones, we have to have something more stringent in place to allow us to do it. Therefore, what we're looking at is the attack agents to understand their capability, capacity and resource to actually mounting attack. And what we need to do is to understand how we can build on those well understood principles from penetration testing and general technical assurance to move them towards actually a much more consistent, a much more rigorous approach for our industrial control systems and critical national infrastructure. So the elements that are missing, I believe, are twofold. The first is detailed threat intelligence, and the second is access to incident-related information. So if we deal with the incident information, for example, currently we have a lot of information exchanges being established. There's a huge amount of information that's coming in there. We haven't actually managed to draw the inferences from that in a way that can be used in terms of providing technical assurance. At the moment, they're providing good information on the types of vulnerabilities and the types of people they're attacking. But what we haven't done is to consolidate those things and draw them together. We haven't done that in terms of the schemes that we operate yet, but it's certainly something we'll be looking at for the future. What we have done is we've looked at the emerging threat intelligence industry. So in other words, those people that are looking at geopolitical, they're looking at big data analytics, they're looking at the traffic that's happening over the internet in terms of people looking at things and attacking the processes, the dark web, and some of the other things that we can actually draw inference from to get a proper understanding of what the threats are like. For the first time ever, since I've been involved in this industry, that opportunity to look at threat and actually do something about it is a real positive thing in terms of both understanding about specific penetration testing, but also the concept of moving to a much more continual threat intelligence, where we can actually do invocation on changes in threats rather than wait for something to happen. So there's a lot of really interesting things happening in that threat intelligence industry. And what we've been trying to do is to draw that forward in terms of moving it into the industrial control systems and critical national infrastructure type activities. In other words, building scenarios that are absolutely relevant and then having red teams or much more structured approaches to actually looking at the attack scenarios that we can replicate to actually mount attacks against those industrial control systems and critical national infrastructure. To date, what we've done is we've developed two specific areas between the UK. The first is CBEST, and that was developed on behalf of the Bank of England as a regulator, UK financial services regulator, with great support from the UK government. What we've done is we've developed that as a concept, and the Bank of England has additional requirements over some of the minimum requirements that CREST would put in place in terms of how it evaluates individuals or evaluates companies. A CBEST activity can only be instigated by the Bank of England. So in other words, a request is made to a financial services organisation, and it's incumbent then on that financial services organisation to demonstrate to the regulator they've taken appropriate action. But it does take input from specialist penetration testers, those that are really experienced, because we don't want to knock systems over. We want to do this in a sympathetic way, but we need skilled, highly skilled people to do this. And in addition to that, we've utilised the information available from the emerging threat intelligence providers to draw that into a particular way of doing this type of an approach. We can draw other derivatives from it that we could then roll out into critical national infrastructure. But that concept in terms of financial services has been extremely successful in the UK to the extent that it's now being used in areas of Central Europe, Hong Kong and Singapore, and it's been looked at by regulators across the globe. If you then move over to other areas, we can't run our financial services without telecommunications. So therefore, our next port of call really was to look at telecommunications providers. Again, it's a UK initiative, but we've drawn inference from some of our friends in Southeast Asia and the United States into this particular program to develop an overall system. We've worked with our National Cybersecurity Centre, we've worked with Ofcom, the regulator in the UK for this area, as well as the departments and also the Bank of England have provided invaluable input in terms of how to develop this. We've done comparisons with existing telecommunications standards in security and other areas. We've fully documented the process of how these types of things can be rolled out, but quite importantly, we've looked at the differences. So the penetration testing community is very used to doing work in traditional business environments. If we're looking at telecommunication systems, we're looking at things like layer 8, we're looking at hard communications protocols, which aren't always evident to people doing normal traditional penetration tests. So what we've done is had some additional requirements for training to make sure that the people fully understand both the language and also the way that the attacks are likely to be done based on the understanding of the environment in which it's working. Again, I think this will be rolled out on an international basis. It's a fantastic piece of work. What we'd like to do then is to start to build on that. We have different categories where if we haven't got access to space, then we haven't got access to satellites, and therefore telecommunications fail. If we haven't got access to energy, then the whole thing falls apart if we can't do transportation. So in other words, what we're looking at those sorts of areas is these are the types of critical national infrastructure services that support all other types of critical national infrastructure. So I'd very like to see the programme in terms of looking at those things specifically, drawing the inference across from the good practice we've done in the financial services and telecoms and rolling those out into other areas. We're already working within the civil nuclear industry, for example, developing those sorts of standards and looking to develop a similar sort of scheme. Once those are in place, we can look at emergency services, some of the water, defence, chemical, food and others, because they're dependent on some of those other things. But again, if we can provide a consistent platform, a consistent approach, then the supply industry can build its capability and capacity to actually resource these sorts of types of things. And also we can start to share information about threats, information about the results and weaknesses we've found, and information about how we can actually improve things across the overall environment. We're also trying to look to establish a coordination group, both domestic and international, to pull together the sectors and also to pull together the international sectors to make sure we're sharing this information and provide a common platform. And again, that view of pulling people together is a really important thing, not just from collaboration, but from the sharing of experience and the full understanding and persuasion that's necessary to raise the level of management awareness about why this is an important thing to do, and also to look for consistencies and how we can overall improve the process for everybody. If we're looking at different areas of the critical national infrastructure, there's likely to be things that are different. The penetration testing industry, as I've said, is very used to working in financial services. Therefore, that concept of building those sorts of things for financial services is quite easy. I do think there'll be some additional skills required for red teaming in certain other areas of critical national infrastructure. We are less used to work within the industrial control systems environment. So therefore, I think in addition to upskilling our penetration testers and our threat intelligence people, we may well have to build joint teams. So in other words, people that understand the deep dive technology associated with their area of the critical national infrastructure to make sure we're coming up with realistic scenarios and we can roll these things out in a consistent way. Threat intelligence, again, has worked very heavily within the financial services industry. That's really where a lot of the drivers for this commercial offering for threat intelligence has come from. But therefore, what we need to do is to establish a market for these services in other areas of critical national infrastructure. I think that will start the process, and the joy of this is if we get this right at the top level, a lot of that threat information will then promulgate down to other areas of less criticality. But in other words, we'll have a much better understanding of the threats that those types of organisations are open to. And finally, the private sector threat intelligence industry is not used to working with there. And I think what we have to do is to look at how governments and the private sector in the threat intelligence area can work more consistently together to come out with things that both protect their intellectual property right, because they're selling threat information, but also make sure that all of the relevant information is available for the common good. In addition to that, there's a great deal of dependence on very specific products within some of the industrial control systems areas. What we need to do is to try to put pressure on those providers to actually improve the current situation. We won't be able to do that in isolation. So again, collaboration is really important. If we're a single organisation going to a particular supplier saying, we want this difference in terms of making sure we have more resilience to a cyber attack, I don't think that will be listened to. If the whole industry comes together and said, we demand this, we want these changes to be made, we want your products to be more secure, then all of a sudden everybody has to react, and we're not always driving down to the lowest common denominator, or our bids are not always associated with being the lowest cost, and therefore security is one of the things that's omitted. And finally, I think the regulators are very different. If you look at the regulators, some have a very stringent requirement, they have very strong teeth in terms of what they can do. Others are much more collaborative and allow the industry to self-regulate. But what we need to do is to understand those differences and be able to move that forward in a consistent way. The regulators have to upskill. I think if they don't understand the threats to which their sector is open to in this area, then they're not going to be able to provide appropriate advice and guidance, and they're not going to be able to provide assurances that these things are in place. And really, that is their job. Finally, what we need to then do is to pull these things together into schemes. Schemes are a combination of trusted organisations and the utilisation of certified individuals. But we can develop a range of schemes that are appropriate for different sectorials and are appropriate for different regulators and different international marketplaces. But the underlying core that sits underneath them should be the same. Otherwise, the duplication will be a waste of time. The attackers aren't duplicating. They're not looking for different attacks for every single different system. What they're doing is pulling their resources together to understand how they can attack in a consistent way. And I think we as an industry have to operate in that same collaborative manner. What we need to do is to understand how this fits as well. The types of things I've been describing for critical national infrastructure are not the type of things we should be doing at basic levels of cyber hygiene, and therefore that criticality in the application of critical national infrastructure type reviews or specific areas that are very critical to organisations must be able to identify and appropriate levels of technical assurance applied. So in other words, we need to be using the right people and spending the right amount of money at the right level within the organisation based on the criticality of the systems. Taken on board the concept that the supply chain will be an important concept. So in other words, for high risk, significant parts of the business or government, then we can use a CBEST or a STAR approach to actually looking at those from a much more consistent way. Whereas right at the bottom of the stack, we can look at things like cyber essentials, basic cyber hygiene, which is trying to protect ourselves against traditional ransomware attacks that you can download off the internet. Those things are very different. The types of controls that are necessary are very different, and the types of people that enact that type of assurance are also different in terms of their qualifications and experience. We can then tie that together with qualifications, both internationally recognised qualifications, and really what we're saying here is there is some specialisation that's necessary at the top, whereas there's much more generic information that can be provided at the bottom. And we can tie those together into ways of differentiating individuals within our industry to provide the appropriate level of service. It's also the case that we can use that as a career pathway where people, if they want to move forward towards the upper levels, then they can do. But we need to understand what that looks like from a certification perspective. And the reason why certification is really important in this area is we need to be able to differentiate. We don't just need to be able to look at a CV or take somebody's opinion of themselves in terms of how competent they are. In addition to that, we need to understand what type of systems and what type of environment we're testing, and there needs to be a process for doing that. But once we've done that, we can then start to apply that to other principles. So in other words, if you've got a non-critical system, we can look at commoditized incident response. Whereas if we're looking at the top levels, things like industrial control systems, things like critical national infrastructure, again, we're going to need some really skilled people to go in there and fully understand what's happened if we've been attacked, or if we've been attacked, because it may have just been a failure. And we need to understand how we can recover it in a structured way that provides assurance that the door is still not left open. In other words, we're just open to attack again. So again, if we have those principles of criticality, we can apply it to not only the technical assurance, but also to the detailed technical recovery associated with cyber-related incident response. It's really a call for action at this point. I think anybody who's interested in this space should read some of the documents we produced, read everything else that's around it, and then contribute. Let's set up forums, let's set up discussion forums, and actually try to move the debate forward in a structured way. You can comment on how the penetration testing and threat intelligence industry should support you as an organisation. If you're working within the industrial control systems or part of the critical national infrastructure, you should really look at what we've done so far and think about how it could be applied to your environment. Review and where appropriate, we can also look at the response maturity model that we've developed. So CREST has a maturity model. The reason for doing that on incident response is if we're looking at testing critical national infrastructure, we can take a test to the point of potential invocation. We can't invoke. So therefore, what you need to do is to have some assurance that there's proper processes in place that would enact a recovery if it was necessary. And I think you need a level of maturity in that area. So not just looking at the technical assurance, but also looking at your ability as an organisation to recover from such attacks. We need your help to help us to develop schemes and mature those schemes and their responses. And again, we need an industry view on that. And I believe in an industry view in a consistent way of looking at the level of criticality, which isn't just based on the sensitivity of the material, it's also based on the availability and the integrity of the information that they process. We need to look at how we define an appropriate incident response structure. At the moment, we understand that from a cyber incident response perspective, malware reverse engineers, intrusion analysts. What we need to do is to understand the type of professionals we need in digital forensics and all of the other areas that would pull together to make an overall recovery team. We need to develop an industry view on the certifications requirements for all of those types of activities, and we need to have a clear pathway for understanding how we differentiate what a good, competent company and a good, competent individual looks like in this space. We can also help to develop and contribute to the debate about how to address those most critical functions. In other words, what type of assurance, and if there's some commonality we can draw across it in terms of minimum standards. We can adopt good penetration testing methods and appropriate for the level, and also you can push the requirements back down into your supply chain. But I think it's inappropriate to start in your supply chain. What you have to do is to demonstrate you're enacting good governance in this area, and then really replicating that good governance in terms of the areas that provide you with direct support. This is a really important type of activity. Critical national infrastructure is potentially at attack. There's always reports in the press from either governments or other people saying that an attack is imminent. We don't believe it's when. Sorry, we don't believe it's if, it's when. That's okay for statements to be made, but in actual fact what we now need to do is to get together as an industry, work collaboratively to make sure we've got appropriate levels of technical assurance in place to ensure that if somebody does mount an attack, we have the ability to identify it, respond to it, and if necessary recover from any incidents that have actually occurred.